All right, let's jump right in. Today we're going to tackle one of the coolest problems in all of AI. How do you teach a computer to actually see? I don't mean just registering pixels. I mean looking at a scene and understanding all the different things that are in it. It's a huge step towards making machines that can truly interact with our world.
I mean, have you ever really thought about it? How does a self-driving car know that's a person about to cross the street, and that's a stop sign, and that's another car? It has to do all of that in the blink of an eye. Well, the answer is a pretty incredible technology, and we're going to pull back the curtain on it today. Okay, so let's get into the nuts and bolts. The magic behind all of this is a field called object detection. You can think of it as the engine that powers pretty much all modern computer vision. It's all about teaching a machine not just to see an image, but to recognize and pinpoint stuff inside it. At its heart, object detection really just boils down to answering two simple questions, but at the exact same time. First, classification. What am I looking at? Is it a dog, a cat, a car? And second, localization. Okay, but where is it in the picture? Any good system has to be a master of both. So what you get out at the end isn't just the word bus. No, it's way cooler than that. The computer actually draws a neat little rectangle around the object, which we call a bounding box. And that box is defined by 4 numbers: its center point and its width and height. This tells the system not just what it's seeing, but exactly where it is and how big it is. Super important. But, getting to this point was a real journey. The whole history of object detection has been this constant battle, this tug of war between two really important things: how accurate you are and how fast you are. For the longest time, you kind of had to pick one. You couldn't have both. For years, the methods were just painfully slow. I mean, think about scanning a huge photo with a tiny magnifying glass, over and over again. It took forever. Then, in 2014, this model called RCNN had a breakthrough. It said, hey, let's first find a bunch of interesting spots, and then figure out what's in them. It was way more accurate, but still, too slow for something like live video. And then in 2016, everything changed. A brand new approach came along and basically created a fork in the road. And this is that fork in the road. The old way, the 2-stage method, was kind of like having 2 people on the job. One person's job is to just find potential areas of interest, and then they pass it to a second person to figure out what's actually there. It works, but it's not very fast. The new way, the single-stage method, is like having one super efficient worker who does both jobs at the exact same time. It predicts the boxes and what's in them all in one shot. And that right there was the key to unlocking real-time speed. And this brings us to the star of our show today, a revolutionary single-stage model with a fantastic name that tells you its entire philosophy. YOLO. It stands for You Only Look Once. Here's the absolute genius of it. Instead of treating object detection like this careful, step-by-step classification problem, YOLO reframed the entire thing. It treats it as one single problem to solve. It doesn't find things and then identify them. It predicts the location and the identity all in one go. It literally looks at the entire image in a single pass through its network and spits out all the answers. That's why it is so mind-blowingly fast. So how on earth does it pull that off? Let's walk through it. First, it divides the image up by laying a grid over it, kind of like looking through a window pane. Then, and this is the key part, every single cell in that grid tries to make predictions at the exact same time, in parallel. Each cell is responsible for any object whose center falls inside it. So they all shout out their best guesses at once: potential boxes, what they think is in them, and how confident they are. Now this is fast, but it makes a huge mess, right? You get tons of overlapping boxes for the same object. That's where the final genius step comes in, the cleanup. A clever algorithm sifts through all those predictions, throws out all the redundant ones, and leaves you with just the single best box for each object. Okay, so that's the theory. It sounds pretty slick, right? But does it actually work in the real world? And, maybe more important for some of you watching, is it hard to actually use? You might be surprised. Just look at this. The single line of code, that's it. That is all it takes to run a state-of-the-art YOLO model on a picture. You load a model that's already been trained, you feed it an image, and you tell it to predict. All of that insane complexity we just talked about is completely hidden away, making this powerful, powerful tech incredibly easy for anyone to use. And here are the results from running that exact code on a picture of a bus. And bam! The model nailed it. It correctly found one bus and 3 people, and for each one, it gives us the bounding box, the label, person or bus, and a confidence score telling us just how sure it is. It just flat out works. So, we've seen that YOLO is smart and it's effective, but let's circle back to what makes it a true revolution. It's speed. Why is that one thing so unbelievably important? Because YOLO doesn't just process images, it can process video at 30, 45, even over 100 frames per second. The old models, they'd be lucky to hit 10 frames per second. This isn't just a small improvement, this is the leap from analyzing a static photo to actually perceiving the world as it moves and changes. This is what real-time really means. And that speed, that unlocks a whole universe of applications. It's what allows a self-driving car to react instantly. It's what powers a security system that can actually track an intruder across a room. It gives factory robots the eyes they need to grab and move things. And it can even help a doctor scan through medical images faster than ever before. So really, when you boil it all down, YOLO's incredible speed was the bridge that took object detection out of the research lab and put it into the real world. It turned a fascinating academic puzzle into a practical, powerful tool that is now all around us, every single day. And that brings us to a final, pretty mind-blowing question. For the first time ever, we have machines that can see, understand, and react to our world with something approaching human-like speed. The technical barrier has been shattered, so the only question left for us is a creative one. Now that they can see, what should we ask them to look for next?